Welcome to the Explainer. Today, we're tackling a topic that is absolutely crucial for the future of our infrastructure. We're talking about greening the cement industry. Get ready, because we're going to decode 10 highly actionable engineering solutions for decarbonizing cement. But first, listen to this staggering fact. Did you know that roughly 7 to 8% of global CO2 emissions come from cement production alone? Yeah, you heard that right. 7 to 8%. If the cement industry were a country, it would literally be the third largest emitter in the world. That single data point makes the stakes incredibly high. We urgently need massive change. Okay, let's dive into this. We actually have a comprehensive 10-step blueprint available. It maps out exactly how we can build stronger infrastructure with a significantly lower carbon footprint. And these aren't just empty theories either. This is proven, actionable engineering. To make it easy to digest, we've divided these 10 strategies into 4 key areas: smarter materials and mixes, greener production and power, logistics and lifespan, and finally, future tech and impact. Let's start with Category 1, smarter materials and mixes, rethinking the basic building blocks. There are 4 fundamental strategies here. 1. Use SCMs. 2. Adopt alternative low-carbon binders like LC3. 3. Optimize the mix design, and 4, incorporate recycled materials. The core idea is that by slightly tweaking our base ingredients, we can drastically drop that embodied carbon while still maintaining full structural integrity. Now, what's really interesting here is SCMs, or Supplementary Cementitious materials. See, the clinker in cement is what produces the most CO2 during manufacturing. So we can actually replace some of that raw clinker with materials like fly ash, GGBS, silica fume, metakaolin, or even rice husk ash. This simple material substitution aggressively cuts down the CO2 emissions for the whole process.
Along with that, technology plays a huge role. These days, we're using AI and machine learning to sharply optimize our mix designs. This data-driven approach tells us exactly how much material we need for maximum strength, which means absolutely no wastage. Add in innovative alternative binders like LC3 and geopolymers, and we are permanently pushing the boundaries of modern civil engineering.
Moving right along to number 2, greener production and power, transforming how cement is made. The contrast here is literally night and day. On one side, we have our outdated traditional fossil fuel kilns, which are massive carbon emitters. On the other side is our critical new goal: next-gen cement plants powered completely by solar, wind, and hydro energy. Just by switching the electricity source for these giant plants entirely to renewables, we reduce their overall emissions by a massive margin. And as for those heat-generating kilns, achieving efficiency really boils down to 3 solid steps. Step 1, upgrade kiln technologies. Step 2, improve heat recovery. And Step 3, optimize processes to reduce fuel consumption. To put it simply, instead of letting all that immense heat just escape into the air, we smartly capture it and reuse it right back in the industrial process. It minimizes fuel use and straight away lowers the carbon footprint. All right, Category 3, logistics and concrete lifespan, smarter movement and longer utility. Now, logistics optimization might sound a bit basic on the surface, but its real-world impact is absolutely huge. We're talking about intelligently optimizing transportation routes, utilizing bulk logistics, and strictly sourcing local materials whenever possible. When you cut down the transportation distance for raw materials and finished cement, that directly translates to major fuel savings and immediate emission cuts. And then there's an incredibly simple but brilliant bit of engineering logic. Just extend the service life of the concrete structures. Yep, it's that straightforward. If we design naturally durable, exceptionally long-lasting structures, we don't have to constantly maintain, repair, or completely rebuild them every few decades. If we build a structure that stands smoothly for 100 years instead of just 50, we effectively wipe out the massive carbon footprint of that future reconstruction today. Finally, number 4, future tech and final impact, the bleeding edge of sustainability. Let's talk about one of the most exciting technologies out there right now, CCUS, which stands for Carbon Capture, Utilization, and Storage. This acts like the ultimate safety net for cement plants. Any stubborn CO2 being produced by the process is captured directly at the source, right before it can be released into the atmosphere. Then we either safely store it or profitably reuse it in other industrial processes. It is a real game changer. The 10th and final strategy in our blueprint is the engine that actually powers this entire framework, supporting research and innovation. Essential R&D investments in new material development, process innovations, and cutting-edge digital tech have to be continuous. This endless loop of innovation is the main driving force that will constantly find new, effective ways to rapidly decarbonize the cement industry tomorrow and the day after that. To sharply summarize everything we've talked about, consider this thought. Sustainable concrete is not just about using less cement. It's about using smart solutions for a better tomorrow. That single statement is the perfect philosophical anchor for today's explainer. Our main goal isn't just to subtract materials. It's about integrating our intelligence and smart solutions to actually create a better tomorrow for future generations. So what is the overall broad impact here? Adopting these 10 strategies holistically gives us a massive environmental return on investment. We exponentially reduce CO2 emissions, we better conserve our precious natural resources, and we lower energy consumption across the entire value chain. All of these well-planned actions collectively push us toward our most critical global target, achieving those vital net zero goals. I really want to thank Global Research Arena, or GRA, for the brilliant visual framework and deep insights that allowed us to explore these incredibly important topics today. Truly eye-opening stuff. So, before we wrap up, I want to leave you with a thought-provoking question. Now that you have this precise 10-step blueprint in front of you, how will you, as engineers, planners, or just informed citizens, champion these smart solutions in your own future projects? Think about it. Knowledge is a great tool, but the right execution is what actually changes the world. Thanks for joining this explainer, and keep building smarter.